Give me just 1 second to share my screen. Okay, today I'm going to go over Module 2 written exam. There are several parts to number 1. Please read the directions carefully. First, let's make a 3-loop Venn diagram showing all 8 of the elements. So right here is the Venn diagram that I've made with 3 loops. And there are all 8 elements, A, B, C, and universal. So moving on to part A. Part A is wanting you to list the union of sets B and C. Union can be explained as what is in B and what is in or C. So you would combine the sets to get the answer. So right here, B has D, F, and H, and C has D, G, and H. So the union of B and C would be D, F, G, and H. Okay, let's go on to part B. We are wanting to find the intersection of A and B. The intersection can be explained with what is in A and B. You would pull out like terms of both of these sets. So A, there is B, C, D, G, and H, and in B there's D, F, and H. So the like terms in the 2 of these are D and H. So that would be your answer there. Moving on to part C. Part C is also wanting you to find the intersection of 2 sets again. This time it wants you to find the intersection of B and C. So B is D, F, and H, and C is D, G, and H. Remember that when you're doing the intersection, you'll just pull out like terms again. So the like terms in this one are D and H. Part D of number 1, we're going to be finding the union again. So the union of A and C. A has a set of B, C, D, G, and H, and C has D, G, and H. Well, A has D, G, and H, so we don't have to repeat it, so it'll just be B, C, D, G, H. Part E, we're going to be finding something a little bit different. It's called the complement. So we're going to be finding the complement of A, and that would just mean that anything that is in the universal set that is not in A. So A has B, C, D, G, and H, and there is not an A, E, or an F in set A. So that would be the answer there. Part F, we would be finding the union of A with the intersection of B and C. So we would do the parentheses first. So B intersecting with C would be D and H, and then the union of A and the D and H would be B, C, D, and D, G, H. You can always refer back to your Venn diagram that you made at the beginning. It makes it a lot more easier, and you can see it visually. Okay, let me see here. Scroll down a little bit. Alright, so number 2 is the same thing, except for we're going to be using shapes instead of letters. So just use the same kind of process that you did with number 1. Alright, number 3. Alright, there are 4 parts to this question. Beginning with part A, please refer to chapter 3, page 127 at table 3.1. It will explain to you what all of these symbols mean. So in part A, it shows 3 pointing fingers equaling 10,000 apiece, 5 yolks that are 10 apiece, and 4 staffs equaling 1 each. So 3 times 10,000 would be 30,000, 10 times 5 is 50, and 1 times 4 is 4. You would add all of these together to equal 30,054, and that would be the answer to what this actually means in digits. So the next one, we're trying to do the same thing. We're trying to find digits from the Roman numerals. So it gives you Roman numerals. You need to find the number that it comes out to be. So there are 2 m's, there's 1 c, there's 3 x's, there's 5, there's 1 v, and then there's 2 i's. M equals 1,000, c equals 100, x equals 10, v equals 5, and 1 equals 1. So 1,000 times 2 equals 2,000, 100 times 1 equals 100, 10 times 3 equals 30, 5 times 1 equals 5, and 2 times 1 equals 2, so that would equal 2,137. In part C, we're doing the same thing. So this one right here will equal 1 apiece, and this one right here would equal 10 apiece. So there's 4 of the 10s, that would equal 40, and there's only 1 of the 1s, so that would equal 41. Let's move on. Here's the last part here. This one, we're doing the same thing. We're going to find out what it equals out to be in digits. This right here equals 5, and this equals 6, 3, and 17. Well, all of these together equal 38,237. In number 4, it's wanting us to solve these equations with the lattice algorithm. So right here, 28 times 32, so you put 28 on top, 32 on the sides. 2 times 3 equals 6. 8 times 3 equals 24. 2 times 2 equals 4, and 2 times 8 equals 16. Well, your answer would end up being 896. Moving on to part B of this one, we're going to be doing the same thing. We're going to be using a lattice algorithm to do another equation. So 273 times 628, which comes out to be 171,444. The lattice algorithm is listed right here. This one right here. And C, we're going to be doing 964 times 593. That actually equals 571,652. Here's the lattice algorithm for that one. Let's move on to a bigger lattice algorithm. 4,952 times 243, which will equal 1,203,336. And here is the lattice algorithm for that one. So, moving on, we're going to round these to the left furthest decimal. So this ends up coming out to be 10. This one here comes out to be 43. Part C comes out to be 91. That will be the end of number 5. So we're going to move on to number 6. 432.5 plus 133.5 will end up equaling 1,125. 414.5 minus 43.5 is 321.5. You can refer to your textbook for ways to do these right here. They're sort of difficult to explain. Alright, that is my Module 2 written exam note.